Welcome you all to session 5 of the chapter Units and Measurements. Whenever we measure a physical quantity, there exist errors. Errors are of two types. One is systematic error and another one is random error. The errors which occur according to definite pattern due to known reasons are called as systematic errors. The errors which occur randomly due to unknown reasons are called as random errors. Now, in this session, we will be learning how to express those errors, that is, expression of errors. Errors can be expressed in three ways. Errors can be expressed in three ways. Okay, there are three ways to express the errors. The first one is absolute error. The first one is absolute error. The second one is a relative error. A relative error. The third one is percentage error. Percentage error. So these are the ways to express the errors. Right? There are three ways to express the errors: absolute error, relative error, and percentage error. Let us understand one by one in detail. Before I go with the expression of errors, let us understand one thing, right? For example, let me take, if I need to calculate what is the diameter of the sphere. Okay, I am considering a sphere and I want to find what is its diameter. So I will be using vernier calipers. So I use vernier calipers and I find what is the diameter of the sphere, right? Okay, when I take vernier calipers and measure the diameter of the sphere, the first time I got 4.53 centimeter. That diameter came to be 4.53 centimeter, right? For the first trial, right? If I remove the sphere and again if I measure what is the diameter of the vernier calipers, second time I got the reading 5.54 centimeter, right? Okay, now again if I do the same calculation once again, third time I got the result 5.52 centimeter. Then the question arises, which reading is correct? In the first trial, let me call it as trial number 1, trial number 2, trial number 3, right? The same experiment I have repeated. So I am finding the diameter of the sphere. In the first trial, I got this result. In the second trial, I got this result. Third trial, I got this result, right? So when I calculate the diameter of the sphere, I got different results. The question arises here is, which reading is correct, right? Which is the perfect reading of the diameter of the vernier calipers, which is what we say now here, actual reading, or let me call it as true value, which is the true value of the diameter, right? So whenever we get like this, true value can be calculated by taking the average of these readings. So do you understand? Whenever we have three readings, okay, let me call it as A1, let me call it as A2, let me call it as A3. So what is the true value? Whenever you want a true value, so we take average of this, right? So what is the true value? True value is, let me call it as A mean, that is A average. How to take average? Add the quantities divided by number of quantities, right? It is the ratio of sum of the quantities, that is A1 plus A2 plus A3 divided by, how many quantities are there? 3 quantities. So I will be dividing it by 3. If I add these 3 and divide by 3, I get A mean. So A mean itself is the true value. There is no other instrument to find what is the true value of the diameter of the sphere, right? So one thing what we need to understand here is, whenever we measure a physical quantity, we measure it more than one time to reduce the errors, right? If I do it 3 times, if I get different readings, so I will be taking mean of it. So that mean gives the true value of the diameter of the sphere. So this is the process that I need to understand, right? So when you come to the lab also, whenever you take the readings more than one time, right? So minimum you will be taking 3 times. Why you are increasing the number of times? Because to reduce the error in the measurement. So to reduce the error in the measurement, you need to take more and more trial, right? As you take more and more trial, errors will be reduced accordingly, right? So do you understand here? Here the true value is nothing but the mean value, right? So after understanding this, how actually we do the experiments. Let me go with these errors now here, right? First one is absolute error, relative error, and percentage error. Okay, first of all, let me go with the first one. What is absolute error? What is absolute error? Right? Absolute error is the difference between, it is the difference between mean value, the already which I took, that is the mean value, right? So difference between mean value and measured value, and the measured value is called, what we say here, absolute error, is called absolute error, right? So difference between mean value and measured value is called absolute error, right? For example, let me take like this. Let A1, A2, A3 be which value? They be the measured values, are what we say here, be measured values in different trials of an experiment, right? So let A1, A2, A3 be measured values in different trials of an experiment. So if we get the three readings, what we need to do? We need to take the mean value. Okay, let me take mean value, that is A mean. Okay, how to take mean value? There are three quantities here. So first you need to add A1 plus A2 plus A3. Mean is nothing but average, right? First we need to add these and divide it by 3, then we get the mean value. If there are 4 quantities, divided by 4, right? Sum of quantities divided by number of quantities gives the average or mean. First thing what we need to calculate? We need to calculate A mean, right? The next here is, what are absolute errors? Do remember, how many trials you make, that many absolute errors we get. Okay, let me go with what are the absolute errors. Okay, let me start with the first one now here, right? Let me take absolute errors in this case. Absolute errors in each case. Let me take now here. In each case, what are the absolute errors? Do remember, absolute error is the difference. Whenever we take difference, we denote it by delta. Do remember, delta means there is difference, right? If there is difference, we take it as delta. Okay, first of all, what are the absolute errors in each case now here, right? Okay, in each case, or let me take now here, in each trials. What is the absolute error in each trial? Let me take now here. What is the first trial? A1. So how to write absolute error? That is delta A1. Right, whenever we take absolute error, let me take modulus. Right, why did I take modulus? Let me tell you now here, right? Okay, modulus means, if at all there is minus, you need to take it as plus now here. That is the way we represent it now here, right? So that is equal to, what is delta A1? It says that difference between mean value. What is mean value? A mean minus mean value and the measured value. What is the measured value? Let me call it as A1. Right. So what is delta A1? A mean minus A1. So what is delta A1? Delta A1 is which error? It is absolute error. What is absolute error? It is the difference between mean value and measured value. Right. So I have measured it 3 times. So I will be getting 3 absolute errors now here. Right. Okay. Let me go with the second one. What is the absolute error in the second trial? That is delta A2. So what do I get now here? That is A mean minus A2. Right. Okay. Now, what is the absolute error in delta A3? That is what we here, A mean minus A3, right? If at all I get minus here, we need to convert it into plus now here, right? So this is the way to calculate the absolute errors. Do you understand what is absolute error? It is the difference between mean value and what we say now here, measured value. Right. If I take the difference between the mean value and measured value, that gives the absolute error. Do remember, how many trials you take, that many absolute errors we get. That is why I have written here absolute error in each trials. Right. So in each trials, absolute error we got 3 now here. Right. So this is the thing what you need to understand. So it is the difference between mean value and measured value. Let me take like this, absolute error. If I want to calculate absolute error, so what is the thing now here? That is mean value difference. Let me take like this, difference, what we say here, measured value. So what is the meaning of difference? Means you can minus mean value minus measured value, or you can do measured value minus mean value, right? Greater minus less. Otherwise, you take modulus to it, so that will give you the absolute error, right? Simple. Absolute error is mean value difference of what we say here, measured value. It is the difference between mean value and measured value that will give you the absolute error, right? When I take the example, you will come to know, right? For example, let me take like this. So this was all about absolute error. How to calculate absolute error? We got like this. Do you remember? The formula for absolute error is mean value difference of measured value. Mean value minus measured value. That will give absolute error, and absolute error is denoted by delta A, right? So delta A1. So this is how we got absolute error. Now let me go on to the next error, that is relative error. What is a relative error? Okay, let me check it out now here, right? So what is relative error? The next one is, what is a relative error? Okay, after calculating absolute error, let me go with the relative error. Relative error, it is the ratio. Do you remember? Relative error is always a ratio. It is a ratio of mean absolute error. It is the ratio of mean absolute error, right? It is the ratio of mean absolute error to the, what we say now here, mean value, right? It is the ratio of mean absolute error to the, what we say now here, mean value, right? Is called, what we say now here, relative error. Simple. Do remember. What is a relative error? Relative error is the ratio of mean absolute error to the mean value, right? Let me write the formula for it. So what is the relative error? Relative error, if I want to calculate relative error, first we need to calculate mean absolute error. Mean absolute error. So how many absolute error we got? 3, right? You need to take the mean of that now, right? So mean absolute error divided by what we say now here, mean value. So this is the formula for what we say now here, relative error. Relative error is the ratio of mean absolute error divided by mean value. Okay, how to calculate it? So delta A1, delta 2, delta A2, delta A3 are the absolute errors. So how to take it, right? Mean absolute error. Take the mean of this, right? Okay, shall I write like this? Instead of writing here, let me take, what is the mean absolute error? That is delta A. Delta A, what we got, that we need to take it as mean divided by mean value. What is that now here? A mean. Right? So delta A mean divided by what we say here, A mean. Or okay, let me write how to calculate the mean absolute error. Means you need to take the mean of these absolute errors here, right? So what does that mean? Delta A1 plus delta A2. So plus delta A2 plus delta A3 divided by 3. This will give mean absolute error divided by what we say here, A mean, right? So mean absolute error divided by A mean, this gives what we say here, relative error. This is how we need to calculate it. So do remember, relative error is the ratio of mean absolute error to the mean value, right? So do remember, and it is denoted like this, delta A divided by A now here, right? So this was all about relative errors now here, right? Okay, the next type of error is percentage error. Okay, let me take like this now here. Here itself, so that let me compare all this error. The next one is, what is percentage error? Simple. Percentage error, the name itself says the error expressed in terms of percentage, right? Percentage error, let me take like this. It is relative error in terms of percentage. In terms of percentage is called, which error now here? Percentage error is called percentage, what we say here? Error. Simple. Percentage error. What is percentage error? It is the relative error in terms of percentage. Okay. How to calculate this percentage error? So what is the relative error? This is the relative error. In terms of percentage means we need to multiply it by hundreds, right? Okay. So what do we get? So shall I write like here? Okay. Let me take here. So what is percentage error? Shall I say like this? Percentage error. So what is percentage error? Mean absolute error. Delta A mean divided by A mean, and you need to multiply it by hundreds, right? If you multiply relative error into 100, what do you get now here? Percentage error. Simple. Percentage error is the it is the relative error in terms of what we say here, percentage, right? So these are the three errors, right? So how to express the errors? There are three ways to express the error: absolute error, relative error, and percentage error. What is absolute error? It is the difference between mean value and measured value, right? So mean value and measured value, that is absolute error. It is denoted by delta A, right? So what is relative error? It is the ratio of mean absolute error divided by mean value. Mean absolute error divided by mean value. So we get relative error. Whenever we get relative error, you need to multiply it by 100 to get the percentage error. So what is percentage error? It is simple. It is relative error expressed in terms of percentage. So this was all about expression of errors. Now let me take a numerical and explain how to calculate the errors. Now let me take a problem, right? Diameter of wire in different trials of an experiment is found to be 2 centimeter, 3 centimeter and 4 centimeter. In the first trial we got 2 centimeter, second trial 3 centimeter, third trial 4 centimeter. Calculate absolute error, relative error and percentage error in this case, right? Okay, now let me solve this. Let me take solution. Okay, how many trials you took in this experiment? 3 trials. So what are those? Let me call it as A1. What is the first reading? 2 centimeter. Let me call A2. What is the second reading? 3 centimeter. A3, that is 4 centimeter. So there are 3 trials. Let me take the reading of the first trial: A1, A2 and A3, right? So already I told you, whenever you take the readings more than one time, you need to take its average. You need to take its mean, right? Okay, let me calculate its mean. So what is A mean? So what is A mean? A1 plus A2 plus A3 divided by 3. First you take the average of this now here, right? Okay, that is equal to, how much do you get? What is A1? 2 plus 3 plus 4 divided by 3. How much do you get? 4, 5, 6, 9 divided by 3. So if I am taking 9 divided by 3, how much do you get now here? A mean is 3 centimeter, right? So what is the average of this? That is 3 centimeter. That itself is A mean. Whenever you take the trials more than one time, the first step you need to follow is take its average, right? A mean you need to calculate. Now after calculating A mean, let me go with the errors now here, right? Okay, so first of all I need to calculate absolute error. Okay, first one is absolute error. Absolute error in each trial. Do understand this, right? Absolute error will be based upon how many trials you take. If you take 3 trials, absolute errors will be 3 now here, right? That is why I told you absolute error in each trial. Okay, first of all, calculate what is absolute error in the first trial. So we know that what is absolute error? Absolute error is the difference between mean value and measured value. So it is denoted by delta. Shall I take like this? Absolute error of the first case, that is delta. What is delta? Delta A1. So I need to take it modulus, right? So what is the use of modulus? If we get minus, you need to take it as plus now, right? So what is the formula for delta A? That is difference between mean value and measured value. A mean minus A1. Okay, that is equal to, what is A mean, man? A mean we got, that is 3 minus A1 is how much now here? 2. So what do you get now here? It is 1 centimeter, right? 3 minus 2, 1. So that is absolute error in the first trial. Okay, now calculate what is the absolute error in the second trial. So how to calculate? That is delta A2. So what is delta A2? That is A mean minus A2. What is A mean? How much do you get now here? 3 minus, what is A2 now here? A2 is also 3. What do we get now here? 0, right? So there is no absolute error in the second trial here, right? We got 0 now here, right? Okay, let me go with the third one. That is delta A3. So what is delta A3? That is A mean minus A3. What is A mean? That is 3 minus A3 is how much now here? 4. Okay, come on, tell me now here. If it is 3 minus 4, you get minus 1. Even though we get minus 1, we take positive because there is modulus here, right? So error will be same here, that is 1 centimeter, right? Okay, we got absolute error. This is a way to calculate absolute error, right? So we have understood how to calculate absolute error. Do you understand? Absolute errors will be based upon number of trials. How many number of trials will be there? That many absolute errors will be there, right? Okay, now let me go with relative error. Okay, first of all, what is relative error? It is the ratio of mean absolute error divided by mean value. We got mean value, but we need to calculate what is the mean absolute error. First of all, before I go with the relative, let me calculate the mean value. Okay, first of all, this is the thing here. Now let me calculate mean value, so that delta A mean I need to calculate, because I need to use it in relative error. That is why I calculate first here. Delta A mean. Also, what is delta A mean? Delta A1 plus delta A2 plus delta A3 divided by 3 now here, right? So shall I take, how much we get now here? 1 plus 0 plus 1 divided by, how much do you get now here? 3, right? We need to add and divided by how many number of quantities are there now here, right? So 1 plus 0 plus 1 divided by 3, that is delta A. I am taking the mean of this. How much do you get? That is equal to 2 divided by 3. If I am getting with the 2 divided by 3, so what is the value of 2 divided by 3? We will get 0.66. Okay, what is it? Delta A mean? So how much do you get delta A mean? 0.66. Why did I calculate delta A mean? Because in order to calculate relative error, you need to calculate first mean absolute error. So this is the mean absolute error. Now it's simple. Now let me calculate that is relative error. Now next I need to calculate the relative error. Relative error. Let me take like this. So do understand how to represent the relative error. Also, what is the relative error? Relative error is the ratio of mean absolute error divided by mean value here, right? Now relative error is equal to mean absolute error. Let me take mean absolute error divided by, what do you get now here? A mean. Okay, what is mean absolute error? That is 0.66 centimeter. Okay, what is mean absolute error? 0.66 divided by, what is A mean? A mean is 3 now here, right? Okay, if I calculate this, I will be getting with 0.22. That is the relative error, right? So this is how we calculated the relative error. Next, what you need to calculate? Percentage error. It's simple. When you get the relative error, multiply it by 100, you get the percentage error. Okay. Next is about percentage error. Percentage error. Let us calculate what is the percentage error. You know what is percentage error? Relative error expressed in terms of percentage, means we need to multiply it by 100 here, right? So when you get 0.22, you multiply it by 100. So how much do you get now here? 22%. So what is the percentage error in this experiment? 22% here. So this is how we calculate percentage error, relative error and absolute errors in an experiment. Now let us move on to the next concept, that is combination of errors, right? How to combine the errors. Before that, let us understand why to combine the errors, right? Okay, now let me take one example. If I want to calculate what is the area of this blackboard, how do I calculate it? First I measure its length, then I measure its breadth and I multiply it. We know the formula for area is length into breadth, right? So if I want to calculate the area of the blackboard, first I calculate length, then I calculate the breadth, right? I calculate this, then I multiply length and breadth, I get the area of the blackboard, right? Okay, whenever I calculate the length, there will be errors, right? Okay, there will be error in length and there will be error in breadth, right? Okay, there will be some error in breadth and there will be some error in length now here, right? Okay, if there are error in these two quantities, what will be the error in area, right? So for that we need to study about combination of errors. For example, let me take another one example like this now here. We need to calculate the density of a substance. So what is density? Mass divided by volume, that is density, right? Whenever you calculate mass, there will be errors here. Whenever you calculate volume, there will be error here. So if there is error in mass and error in volume, what will be the error in density, right? To understand that, we need to go with combination of errors now here, right? So this is the reason why we will be studying about combination of errors, right? Okay, so do understand, we will be combining the physical quantities, right? So to calculate the error in the final result, we need to know about combination of errors. Okay, to calculate the errors in the final result, there are some rules that you need to follow, right? Let me go with the first rule, right? what is the rule number 1? That is first rule. When two quantities are added or subtracted. So do you understand? In the first rule, let me tell you what will be the error in the final result if we are adding the physical quantities, right? Adding or subtracting now here, right? When two quantities are added or subtracted. When we take adding or subtracting, we will be considering the absolute error. Okay, when two quantities are added or subtracted, the absolute error in the results, is the sum of absolute errors in the individual quantity. Okay, let us understand about individual quantities now here, right? Okay, the first rule says that when two quantities are added or subtracted, let me take two quantities, I will be adding and subtracting now here. The absolute error in the result is the sum of absolute error in the individual quantities, right? For example, let me take z equal to, what is z equal to? A plus b. There are two quantities, I am adding it, I am getting it z now here, right? For example, right, if I am taking one rod here and I will be considering another one rod here. First, I will be measuring length of this rod, right? There will be error now here, right? Then I will be calculating what is the length of this rod. Again, there exists what now here? Error. So let me take, what is L1? Let me take it as A, and what is L2? Let me take it as B. Now what I will be doing, I need to calculate what is the length, the total length of the rod now here, right? It is nothing but what we say here, Z. So what is Z equal to? A plus B, means total length equal to L1 plus L2, right? In general, and I'll be using A and B, right? So when two quantities are added or subtracted, what I am doing here? Now I am adding here, right? So if I am adding, or let me take another one, that is subtracting A minus B. What we need to do? Whenever there will be addition or subtraction of the physical quantities, which error we need to consider? Absolute error. Do you understand? Right? We need to consider absolute error. So what is absolute error? It is the difference. So we need to take it as delta now here, right? So what is the absolute error in the result? So what is the result here? Z is the result. So what is the absolute error of Z? How to denote it? Absolute error of Z is delta Z, that equal to. Understood? It is modulus now here, right? So delta Z equal to. So what is that? Absolute error in the result is the, what we say now here? Sum of, right? It is the sum of absolute error in the individual quantities. So what are the individual quantities? A and B. What is absolute error in A? Let me take it as delta A. What is absolute error in B? That is delta B. Do you understand? Right? So delta Z equal to delta A plus delta B. We need to add the absolute errors. If you add the absolute errors, we get the error in the final result. So this is rule number 1. So do remember, rule number 1 speaks about addition and subtraction of the physical quantities. So we need to take which errors? We need to take absolute errors, right? If you get absolute error of L1, absolute error of L2, we need to add it to get absolute error in L here, right? Okay. Do you understand? This is the rule number 1, right? Rule number 1 tells about what we need to do when there is addition or subtraction of the two physical quantities. Okay, let me go with rule number 2 now here, right? So let me take rule 2. Okay, what is rule 2? Rule 2 speaks about multiplication and division. When two quantities, let me take, when two quantities are multiplied or divided. When two quantities are multiplied or divided here, right? Okay, when you are multiplying and dividing, the relative error in the result, in the final result, is the sum of relative errors. Is the sum of relative errors in the individual quantities. Do understand here, right? Okay, when two quantities are multiplied or divided, when there is multiplication or division, which error we need to take? A relative error, right? For example, density. What is density? Mass by volume. There is a division. So which error I need to take? A relative error, right? Do you understand? If there is addition or subtraction, take absolute error. If there is multiplication and division, take relative error. Okay, let me take an example here, right? Okay, general example, let me take Z is equal to AB, right? A into B, right? Okay, then Z equal to A into B. It is like that. Momentum equal to mass into velocity, right? It is like momentum, it is mass, and this is velocity now, right? Okay, then Z equal to, what do you get now here? A divided by B, right? Multiplication or division. This is density equal to mass by volume type now here, right? Okay, now if the formula is like this, so in order to calculate what is the error in the final result, which error I need to take? I need to take a relative error. What is relative error? It is a ratio, right? Ratio of mean absolute error divided by mean value. So how to write relative error of Z? Relative error of Z can be written as delta Z divided by Z, right? So do remember, relative error of Z can be written as delta Z divided by Z. Okay, absolute error of Z is written as only delta Z, because it is difference, it is the ratio, right? Okay, now that is equal to, what is the relative error of A? That is delta A by A, right? Is the sum of relative errors in the individual quantities. Let me write, it's the sum of individual quantities. What are individual quantities? A and B. So delta A by A plus, what is the relative error of B? That is delta B divided by B, right? So this is the second rule. Do you understand? Whenever there are two quantities which are multiplied or divided, which error we need to take? Relative error. Relative error in the final result is the sum of relative error in the individual quantities. Do you remember? Whenever there is multiplication or it may be division here, right? The rule remains the same. We need to take plus itself, right? Here also, whenever there is plus or whenever there is minus, again we need, in the errors we need to consider plus itself, right? That is why I told you, if the two quantities are added or subtracted, relative errors must be added. Here also relative error must be added. Sorry, here absolute error is added, here relative error is added based upon addition and subtraction, and here multiplication and division, right? Okay, based upon the mathematical operations, we need to decide which error we want to take, right? So during addition and subtraction we take absolute error, during multiplication and division we take a relative error, right? Okay, this is rule number 2. Okay, let me go with the rule number 3. What is rule number 3? There are 3 rules to be followed whenever we combine the errors. Okay, rule number 3, it says that when a physical quantity is raised to the power of k. Okay, when a physical quantity is raised to the power k now here, right? Okay, whenever we are raising the power, right? When a physical quantity is raised to the power k, the relative error in the final result, right? The relative error in the result is, okay, so what is the relative error in the result? The relative error in the result is k times the relative error, k times the relative error. See, when a physical quantity is raised to the power k, the relative error in the result is k times the relative error, right, of the individual quantity, right? So k times the relative error in the, what we say now here, individual quantity. Simple. Okay. Rule number 3 speaks about if there is a physical quantity which is raised to the power k now here, right? Okay, let me take one example so it will be clear to you, right? Okay, now I am speaking about rule number 3 now here, right? So this is rule number 1, rule number 2, rule number 3. It says that if there is a physical quantity like this and it is raised to the power k, right? So z equal to a raised to k, right? If it is so, then what we need to do, right? Whenever you find the quantities which is raised to the power of something now here, again we need to take which error? So first you have to understand that we need to take which error? Relative error, because it is nothing but a multiplication, right? If it is a square, a into a, so it is again one form of multiplication, right? So I need to take a relative error itself, right? Relative error in the result. So what is the result here? Z, So what is the relative error of Z? Delta Z by Z. Do it. Whenever we take relative error, it is the ratio delta Z divided by Z. That is equal to. So what does the rule says? When a physical quantity is raised to the power k, the relative error in the result is how many times? K times the relative error in the individual results. So this is k times. If it is power k, we need to write k times the relative error in the individual quantity, that is delta A divided by A. This is rule number 3, right? So do you understand what is rule number 3? Whenever there is a physical quantity which is raised to the power k, then the relative error in the result is k times relative error in the individual quantity, right? For example, I think you have heard about the formula for kinetic energy, right? So what is the formula for kinetic energy? Half mv square. Right? Did you get a physical quantity raised to the power of something here, right? If in this case I need to consider this rule, that is rule number 3, right? So I'll be solving some numericals so that you'll come to know how to apply these rules while combining the errors. So these are the 3 errors: rule number 1, rule number 2, and this is rule number 3, right? These are the 3 rules you need to follow whenever you need to combine the errors. Okay, let me summarize. Whenever you add the physical quantities, which error you need to consider? Absolute error. Absolute error in the final result is the sum of absolute error in the individual quantities, right? This is how, right? If you see that there is multiplication or division in the formula, right, then which error we need to take? Relative error. Relative error in the final result is the sum of relative error of the individual quantities. If there is a formula in which physical quantity is raised to the power of something, then which error we need to take? Relative error. Relative error is equal to k times the relative error of the individual quantities, right? A raised to k, that is k into delta A divided by A. Okay, one thing be clear: if there is a quantity A, what is the absolute error? Let me tell you how to denote this. What is the absolute error of A? That is delta A. What is the relative error of A? Delta A by A. This is how we represent. Do you understand how to represent the errors, right? I have used here representation. If there is a quantity A, absolute error of A, it is represented by delta A. There is difference. I already told you, delta means difference, right? So what is the relative error? Delta A by A. Okay, so do understand this so that I'll be solving some numericals based upon the combination of errors. Let us go with the first numerical. Temperature of 2 bodies are found to be T1, this is the first temperature of the first body, right? 20 degrees Celsius plus or minus 0.6. And temperature of the second body is 50 degrees Celsius plus or minus 0.4. So we need to find what is the sum of temperatures. So what is the sum of temperatures, right? Okay, here one thing what you need to understand, if it is given like this, what is the meaning of this? 20 degrees Celsius plus or minus 0.6. The meaning of this is the temperature varies from 20 plus 0.6 means what? 20.6. 20 minus 0.6, that is 19.4. So it is in this range. Okay, now we need to understand what is the meaning of this here. This is nothing but what we say here, error, right? So it is the error. Which error? It is the error of a particular quantity. So this is absolute error, that is nothing but, if it is A, right? If it is A, it is delta A. Did you understand, right? If it is A, what is this? This is delta A. Do remember, if the quantity is given like this, what is the meaning of this? This is nothing but error, right? This is error in this quantity, means it is which error? It is absolute error. So let me take it as delta A, right? Okay. So after understanding this, let us solve this problem. Okay. There is first temperature. What is the first temperature? 20 degrees Celsius plus or minus 0.6. And the second temperature is 50 degrees Celsius plus or minus 0.6. Okay. Let me find what is the sum of temperatures including errors now here, right? Okay, first of all, let me call the sum of temperature. Let me take T is equal to T1 plus T2. I need to add this now here, right? So whenever I need to add this, first of all, add without considering errors, then add considering errors, then combine both, you will be getting the total temperature considering error now here. Okay, first of all, calculate without considering errors, means don't consider this errors now here, right? First of all, don't take the errors. First, to calculate what is the sum of the temperature. So what is the sum of the temperature? T is equal to T1 plus T2. So what is the sum of the temperature? T1 is 20 degrees Celsius plus T2, what is T2 now here? 50 degrees Celsius. How much do you get now here? 70 degree Celsius. This is the temperature without including the errors. Now we need to include the errors, right? Okay. Now let me calculate including the errors, right? So what is this? Which mathematical operation is this? This is addition. So whenever there is addition, which error we need to consider? Absolute error, right? Okay. What is the absolute error in the final result? What is the absolute error in T here? That is delta T. That is equal to absolute error in T1, that is delta T1, plus what is the absolute error in T2, that is delta T2, right? Absolute error in the final result is the sum of absolute error in the individual quantities. Okay, now come on, tell me, what is delta T1? Absolute error in the temperature T1. What is the absolute error? 0.6, right? Let me take 0.6 plus what is the absolute error in the second temperature? So what is that now here? 0.4. 0.4. How much do you get now here? 0.6 plus 0.4 is 1. Now, what is the total sum of temperature? The question is asked to calculate what is the sum of temperature. What is the sum of temperature? T is equal to, right? First, without error. So, without error, how much it is now here? 70 degrees Celsius. So, with error, we get absolute error. What is that now here? 1. So, let me take plus or minus 1. Right? So this is the answer, right? So do understand. What is the sum of temperature? What is the sum of temperature? 70 degrees Celsius plus or minus 1, right? So this is how we have calculated the sum of temperature of the two bodies. Simple, right? So this is how we have used the rule number 1, right? Whenever two quantities are added, which error we need to take? Absolute error in the result is equal to sum of the absolute error in the individual quantities, right? So this is how we have calculated, and we got T is equal to 70 degrees Celsius plus or minus 1. Do you remember the quantity which is given here? What is the meaning of this? This is absolute error, right? So what is the meaning of this? This is absolute error. So what is the meaning of this? This is also what we say here, absolute error, right? Okay. So this is how we calculated the first problem. Let me go with the second problem, right? What is the second problem? Let us check it out. Okay, the second problem is like this. Length of the rectangle is given. So what is the length of the rectangle? 3 plus or minus 0.1 meter. The breadth is given. Okay, let me take now here. Solution. So length is given. What is the length given now here? 3 plus or minus 0.1. It is in meters, right? Okay. A breadth is given. What is the breadth now here? 2 plus or minus 0.1 meter. Okay. Come on, tell me, what is 0.1? It is the error, absolute error in L. What is 0.1? Absolute error in B, right? Okay. First of all, in order to calculate, what we need to calculate, first understand here, find the area of the rectangle and percentage error. First we need to calculate area, then I will be calculating percentage error. Okay. First of all, area we need to calculate. See here, everybody. How to calculate area? That is, area is equal to, what is the formula? It is the area of a rectangle. So what is the formula for area of rectangle? Length into breadth, right? So what is the length into breadth? First of all, you need to consider only the quantity without considering the errors. Okay, first of all, what is that now here? 3 into breadth is how much now here? 2. That is how much do you get here? 6 meter square. And this is the value of area without considering errors. Now I will be considering the error, right? But it is not complete now here, because we are not considering yet errors now here, right? Okay. Now I will be considering about the errors. When we consider error, just think it out. Which mathematical operation is it? It is which mathematical operation? Multiplication. Whenever there is multiplication, which error we need to consider? We need to consider the relative error. So what is the relative error of area? Let me take it as area. Let me denote it by capital letter A. Relative error in A. So what is relative error in A? Delta A divided by A. Right? We know how to calculate. Relative error is the ratio. Right? Delta A by A. That is equal to, what is the relative error of L now here? Delta L by L plus relative error in B, delta B divided by B. Why did I take relative error? Because it is multiplication. Whenever there is multiplication, which error we need to consider? We need to consider the relative error. Okay, let me write here. What is the delta L? Come on, tell me. This is delta L, right? 0.1. What is L? This is nothing but this 3, right? Plus, what is delta B? This is delta B, error 0.1. What is B now here? That is 2 now here, right? Okay. 0.1 divided by 3, right? If you calculate 0.1 divided by 3, you will be getting with 0.03 plus 0.1 divided by 2. So if you calculate it, you will be getting 0.05. So if you add this, you will be getting with 0.08. That is the relative error, delta A by A. How much did you get now here? 0.08. So we calculated error part now here. Then we will be combining both now here, right? So what is area of a rectangle? The area of rectangle is equal to, right? So without error, how much did you get now here? 6 plus or minus. We calculated error also, that is 0.08, that is meter square. This is how we express it, right? So area of rectangle is equal to 6 plus or minus 0.08 meter square. This is area of a rectangle. Now we will be calculating what is the percentage error. You know how to calculate percentage error. The formula for percentage error is percentage error, that is equal to a relative error into 100. Right. So what is percentage error of what now here? Area. That is relative error. So how do you write? Delta A by A into what we say here? 100. Relative error expressed in terms of percentage. So what is delta A by A? We calculated it. How much did you get now here? 0.08, and we need to multiply it by hundreds. If you multiply it by 100, how much do you get now here? That is 8%. This is how we calculated percentage error, right? Percentage error is equal to relative error into 100. Relative error expressed in terms of percentage is called as percentage error, and this is how we solve. Whenever the problem is given, first we need to know what is the formula for the result to be calculated, that is area is equal to length into breadth. Here there is multiplication, then which error we need to consider? Relative error. So relative error in the final result is equal to sum of the relative error of the individual quantities. So we have calculated error and we combine and we have written what is the area of rectangle, then we calculate percentage error and it came to be 8%. Okay, now let me solve the last problem and conclude this part. The percentage error in the measurement of mass and velocity, okay, are 2% and 3%. Means the percentage error of mass is 2%, percentage of velocity is 3%. Respectively, what is the percentage error in kinetic energy, right? So percentage error of mass is given, percentage error of velocity is given. We need to calculate what is the percentage error in the kinetic energy. Okay, let me solve this. First of all, you need to know what is the formula for kinetic energy. Okay, let me write like this. What is the formula for kinetic energy? The formula for kinetic energy is E equal to half mv square. Okay, the kinetic energy, the formula is half mv square. We need to calculate what is the percentage error in the kinetic energy. Means what is the percentage error in E now here, right? Okay, so in order to calculate percentage error, okay, first of all we need to find how to calculate the error in this formula now here, right? So there is multiplication. So which error I need to consider? First I will be going with the errors, right? Which error I need to consider? Relative error. Why relative error? Because there is multiplication, right? So what is the relative error in E? That is delta E divided by E. Relative error, that is equal to, right, half. It is a constant and it will not be having any errors. Right, do remember in the formula, if you have number, it will not be having any errors. So you need to not consider this half now here in errors. Okay, what is the error in m? Delta m by m. Which error we need to consider? Relative error, because there is multiplication here, right? V square, apply third rule. What is third rule says? When the physical quantity is raised to the power k, then the relative error in the result is k times the relative error in the individual quantities. Right, since it is multiplication, let me take plus. What is the error in v square? What is that now here? 2 into delta v divided by v. Physical quantity raised to the power k is equal to k times the relative error of the physical quantity. Do remember, right? If it is v square, we need to consider 2 into delta v divided by v now here, right? So what is given now here? Percentage error is given, right? So in order to calculate what is percentage error? So relative error in terms of percentage. Shall I multiply 100 to all the terms here? Okay, what shall I take now here? Delta m by m into 100, that is equal to 2 delta v by v into what we say here? 100. This is nothing but relative error into 100, that is nothing percentage error in mass here, right? Sorry, it is not equal to, it is plus. So this is also what we say here? percentage error, right? So this is percentage error in what we say here, energy, that to kinetic energy. Okay, that is equal to, what is error in mass now here? What is error in mass? 2% plus 2 times of, what is percentage error in velocity? That is 3%. So 2 times of 3%. So how much do you get? 2% plus 6%. So what do you get now here? 8%. So what is the percentage error in kinetic energy? So this is the percentage error in the kinetic energy. So what is percentage error in kinetic energy? That is 8%. Do you understand how did I get it? Okay, once again, if the question is asked like this, first we need to calculate kinetic energy. We need to know formula for kinetic energy. E is equal to half mv square. Let me go with errors. To know errors, first you need to check it out which mathematical operation it is. If it is addition or multiplication, go with absolute. If it is multiplication, if it is addition or subtraction, go with absolute. If it is multiplication or division, go with relative. Since it is multiplication, I went with the relative. Delta E by E is equal to half. It will not be having any errors, so I will not be considering that. What is error in M? Delta M by M. Since it is multiplication, I need to take a plus here, right? So V square. So we need to take 2 into delta V by V, right? So since percentage errors are given, so I will be multiplying all the terms by 100 here, so that we get the percentage error here, right? This is nothing but percentage error is 2%. 2 percentage error is 3%, so we have calculated 6%, we have got 8%. So this is how we calculate the combination of error problems, right? The question is given like this and we need to calculate, and we will be using the rules of combination of errors and solve these kinds of problems. So this is the end of combination of errors. Thank you.